Great, thanks everyone for coming out. My name's Jared Smith, and I'll be talking about threat modeling, Python, Flask, and Django apps, as well as general security concerns with Python web apps. So a little bit about me. I'm from Knoxville, Tennessee. I'm also a cybersecurity researcher at Oak Ridge National Lab, which is one of the U.S. Department of Energy's largest labs. So we came up with plutonium back in World War II, built the atomic bomb. We just discovered a new element. But we do have a cybersecurity group there, so we do work for all kinds of people. I'm also a PhD student at the University of Tennessee, Knoxville. Go Vols. We suck right now, but we're getting better, I think. So if you follow football, please keep us in your prayers. I'm also a guest teacher at Treehouse, which is kind of like Pluralsight, and I teach security, DevOps, and some other courses there. And I do like hiking, so if you ever go to Tennessee, there's lots of hiking, so please go. So the first thing we're going to talk about is threat modeling web apps in general, and kind of catering it towards Python applications. So you can think of threat modeling, let's start by thinking about it as a house. So you might have jewelry in your house, and that jewelry is an asset that you want to protect and keep safe. So now you have doors in your house as well, and those are features. Think of them like a piece of code that's an entry point into your code base, like the front end. And that door is what is protecting your house from people coming in and stealing that jewelry or your other assets. And now if that door is left open, we would consider that something like a vulnerability. And if that door is open and someone gets in, steals the jewelry, then that's a vulnerability we didn't know of and we weren't able to patch and we weren't able to keep it closed to keep people out. So in general, that's kind of the whole big picture around security, is looking, at least in software security, is looking at the application you have, understanding how it works and how it interacts with the world, and finding the areas where it might be able to be compromised, and then dealing with mitigating those areas. So the first step in a pretty simplified threat modeling process is to identify the assets that your application has. So in the case of a house, that's things like your jewelry, your car, your family, your dog, all of those things. I mean, it's pretty abstract there, but in an application, that's things like your critical data in your system, different admin portals, again, credit cards, anything like that you want to keep safe. So once you've identified, or once you've understood your system, you need to actually get in and deeply understand the application. And so a lot of people start out by doing this by drawing diagrams and writing lists about how their things work. The general point here is, if you're going to do some kind of diagram, is to stay away from stuff like this. So this is real, and I tried to understand it, but it seems like some kind of banking system. It might even see there's New York Stock Exchange here, there's a store in here, there's inventories. This might not be software, this might be 200 years old, but this is not what you want to draw. So something more along the lines of how you might want to start understanding your application is something like this. So you have your databases up here, you have your front end, which I ripped this picture offline because I was not about to draw this. So do not hate on me for it being backbone. So then you have your REST API that could be Django, using Django REST framework, which communicates with your backend portal with your models. That talks to the front end through some router on the front end. So this kind of gives you an understanding of where all the different areas in your app, how data flows around, and that's what we're going to talk about in just a second. But you can see here every channel is labeled with the protocol that it speaks over. So for example, that's TCP/IP and REST. Through here, it's a JSON API. Knowing these things about your application is the first step to understanding where to patch up vulnerabilities and where to look for those things. So in understanding the application, in the order of the things you should look at is, first is trust boundaries. So what does this look like in an actual Python application? So you see here we have a form. This is a pretty standard HTML form using what will be pulled into Django. So the endpoint for it is search. It's a post form, and it takes a query right here. So that's going to be fed into the view, which I'm going to show you in just a second. So this form is defined by this Django input form. This is just pretty standard Django. If you want to define a form, you inherit from the class. And this query is the field, is that search query field. So again, we define some validation on it. Something like max length is 100. And here in this view, we have a bunch of standard imports, and this is a Django view. So think of you're routing the different parts in your application. So this search query, what it will do is if you are posting to the form, then it will decode the form, check whether it's valid, and then what it will do is look up inside your database using the database result model This is standard Django ORM, and give you all the results that match that query. Something else we're also going to do is say you have a caching layer like Redis. Is most people familiar with Redis, caching in general? So yeah, the goal is you want to cache different things to keep quick access to your objects. So both of these things here, in the case of this search form, these are both two trust boundaries at which you're taking input from a user, a developer, some API, and you're passing it to another layer of trust. And there's some kind of implicit trust here. So the first thing that we do is we expect that this form data from this query is sanitized. If it's not sanitized, that might be an issue. In the case of Django, this should handle it because you can't really do SQL injection with an ORM form, and we'll talk about that. But what can happen is that we do no such sanitization on this Redis client caching area. So if we input some data there, who knows what it could be, but there might be a way you could poison it or do something weird there. So the first step to understand your application, one of the first steps is identifying the trust boundaries and how you trust data moving across different areas. So we just talked about trust boundaries. So what about data flow? Data flow in general is, think about it as if you tweet, maybe you put a tweet on Twitter, and that tweet is only in your client when you post it, but then it gets passed through the backend to all the other different clients out there. Now, if Twitter had a vulnerability where you could input some script in that tweet and every other person that showed up on their homepage was then compromised and downloaded malware and then served, botnets and things like that, then we'd have an issue. And that is exactly what we mean by data flow. So how does data flow throughout your application? So in the case of Python, we have another form here, but this is now Flask. So we have a login form right here. And data flow is really fun to think about when you think about microservices. So of course, you think about data coming from your front-end application. That's obviously an area where data flow happens into a form, but we just looked at that. So what about another scenario? So here we have the same kind of thing as Django. We have a form, and if someone posted the form, then we validate it. And then what we do is we pass along the user object that logged in on that page to another microservice in some other part of our application. So that's a common thing you might want to do is separate your login microservice or separate different microservices around. And at the point at which you pass that user object without doing any sort of validation, that's a way that data is flowing. I mean, whether it's validated or not, that's just identifying that data is flowing between those two areas. The rest of this is just standard Flask. But to illustrate things like trust boundaries, so we talked about data flow, and going along with data flow is these things called entry points, and that's pretty standard. It's what you'd think it would be. So that's things like the front-end interface. We talked about forms, microservice calls. We just looked at that. Management interfaces, so if you have an admin page, you want to make sure that's secure. Things in Flask and Django don't have SSL by default, so it's definitely something you want to have in your management interface if you're modifying things. And then services in the backend server, so if you're running a Redis database or Redis caching database or Postgres, whatever, you want to make sure you're watching how you're calling those things. So we talked about trust boundaries, data flow, entry points, and the last step to understanding your application is identifying privileged code and privileged areas in your code. A lot of these things kind of interrelate, but when you talk about this, imagine that you're calling some Python file, and that file is starting up some system services. So this is a pretty contrived example, but to illustrate this, you probably need sudo on a Ubuntu machine to run all of these things. So think about this in the concept of, you got Ansible or SaltStack configuring different parts of your machine. You're probably going to call this with sudo. Now, if some way there's some other code in between here that took input from somewhere else and someone was able to compromise this process, well, great. Now they're root, and they can do whatever they want on your machine, insert whatever they want, steal whatever they want, because you've just run that with root. Obviously, you have to do that sometimes, but that's illustrating that at this particular application, if there was other code here and something got in, then now they're in a privileged area because you're running it as root. So now that we've understood our application, the next thing you're going to do is identify threats and vulnerabilities. And I'm going to get into, after this generic threat modeling section, a bit about vulnerabilities in common Flask and Django apps and kind of go through this. But the general goal here is that you want to look at all these things that you've understood about your application and identify places where you have a lack of security, or you have not sanitized different areas, or you've not considered the data flow. So the first step to doing this is actually understanding the threat. And so what do we mean by that? This is where I like to pull in these dudes. So those are, black hat, white hat hackers. And when you think about hats, we talk about black hat and white hat. So they're used to classify hackers by their motivations. So, I mean, it could be anyone. I mean, it could be, a 2-year-old kid. It could be some dude or girl or whatever. Everyone has different motivations, and you have to realize that. So it's helpful to understand these motivations. So it could be things like money, power, destruction, morality, responsibility, protecting innocent people. People do all kinds of different things, and just watching the news, you see all of these motivations come out. So white hats, I like to think about people in NCIS. So here is where you can type. If you type at the same time, 2 people, then you can actually work faster in your machine. So those are white hat hackers from NCIS. But those kinds of people are usually security researchers. You're a pen tester at some company. You're trying to secure applications before other guys break in. They practice responsible disclosure. So you find a bug. You don't just go and publish it in a blog post and watch the world burn. You disclose it to them, and then let them fix the vulnerability. And only if they don't fix it within a reasonable amount of time, then you publish it, because you need to tell everyone since they're not being responsive. There's a whole practice around that. I won't get into that, but you can look into it. So they might participate in bug bounties. These are these great things where now, instead of companies locking you up in jail, they let you actually hack into their applications. And they spread security awareness. And finally, they do maintain active Twitter accounts. So the notion that security people are not online ever, they are all over the place. Just look them up. So black hats are these dudes. Does anyone know what movie this is from? Hackers. Yes. It's from Hackers. So this is what a bad guy's operations center looks like. This scene after this shows them pivoting through all kinds of binary, and they start typing the screen like a Pac-Man cookie monster starts eating cookies. It is a great movie. There's lots of movies like this. But please, if you're a bad guy, you have to have lots of pretty lights like this. So these people have lots of motivations, and these are certainly not all of them, but a few of them are things like money. So the LinkedIn data breach, people stole the data and started selling it. That was 2012. If you had LinkedIn before 2012, you should probably change your password. Power, North Korea versus Sony. I'm sure there was other stuff here, but there is issues with that. Destruction. So people do things like bring down entire countries' power grids just to, again, compromise their utilities, do other weird things like that. Revenge, so hacktivists and the anonymous group, the people with the V for Vendetta hats, they might do this to take revenge on someone. And finally, politics, whether this is actually true or not, that's a thing. People do compromise things on political basis. So there's lots of levels of attackers. So the first one is someone accidentally discovers your application. Or they accidentally discover a vulnerability in the application. They may not be as adept or sophisticated as an attacker as someone that's actually a security researcher, and they're going to go investigate it until they find something wrong with it. Those two are different types of people, and the whole goal here is to understand the different type of people that would attack your application. So if you're Bloomberg and you're building terminals that let you access financial data in every company in the world, you obviously have bigger problems to worry about than me deploying a test app for a toilet paper delivery service in my garage. Script kiddies, so those are people that just download scripts online and just run whatever they want, and hopefully they find a bug, and if they do, they show all their friends. The motivated attacker are people that actually want to, that are going to keep trying and trying to get into your system until they do. Organized crime, unfortunately, this is a thing, and when you put enough people together for working for the same purpose, they will get in. And finally, if you have any nation states going after you, you're pretty much, you're done at that point. You can defend against these people, but when you talk about security and at least academia and more formal ways, those are people with unlimited resources, or essentially unlimited resources. So you have to be very careful about knowing your threat model. So once you actually identified or you understand the attacker, the goal is to investigate and find those vulnerabilities and prioritize them according to which ones need to be fixed first based on your threat model and which people you expect to be coming after you. So that's kind of where we get into finding these, and that's what I'm going to talk about in the next section on Flask and Django vulnerabilities, at least common ones. So once you've identified those, the goal is to prioritize and fix them. So this all revolves around something called risk. And this is very, very hard to actually to define. But when we want to define that, basically the way we can do it is we can take two things, likelihood, so assigning a score of likelihood to exploit, So how likely is it to bring down the site? Can you compromise data? Can you take over users? If you can do any of these things very easily, then it's more likely to happen. And then you want to look at impacts. So you have a higher impact if you can compromise more data. You have a higher impact if financials are affected or you bring down the internet. You have a lower impact if few people are affected, there's not critical data, or maybe the New York Times doesn't write about you and plaster your company on the front page. So when you combine these two things, a very simple score is taking your risk and multiplying, and that is the multiplication of likelihood and impact. And you use this risk score for every single vulnerability you find or you have found to prioritize how to fix them or in what order to fix them. Because face it, we don't have unlimited security resources, and as much as people like me will come up here and preach that security should be built in the process from the ground up, it isn't always, and we have to apply things on the back end sometimes. I hope not. So the second section is common vulnerabilities in Flask and Django apps. So we've talked about the general threat modeling process. Now, what are those vulnerabilities? So the legend here is that anytime I say framework, I'll put Flask and Django after it and then put a link to some things. I won't have the full link in there. It'll just be underlined, but I'm going to post these slides online, and they'll be with the talk. And then finally, if I have any blue circles, it's like a takeaway. So SQL injection. SQL injection is essentially when you don't sanitize data going into your application, and what you can do is get all the data out of your database. You can drop all the data, whatever. Most of the time, you are safe from this in Flask and Django if you use the ORM. I don't want to say all of the time because who knows. But in cases where people do stuff like this and they string interpret something and you take a username from your front end and then you just throw that in, well, what you can do is in the normal case, some normal user, your normal API will just say, hey, get the attendee Jared from this conference. And then that'll say, select Jared from attendees where attendee equals Jared. So what if we do get attendees and then encode something called delete from attendees? That'll turn into this. And what that'll do is delete everything in your attendee database. And then you're basically screwed at that point. So that will not happen in pretty much all cases with Flask and Django because both of them use ORMs or you have to use the built-in database model. But if you do want to execute raw SQL, always use prepared statements, bind the parameters to the variables, and then it will sanitize it or it will escape it for you. So again, we're going to see this over and over, that you never want to trust user input without sanitizing it first. That is what will bite you 90% of the time in most web applications. So command injection is a more generic form of SQL injection, when we run a command on the server. So think of something like remote code execution. But an example here is what if you take a path to, or you take a receipt name. So the receipt has a name that's a user. And you want to get the receipt for that user for their conference registration. So what you do is you name the receipts after their name, and all you're going to do is find the path on your machine where that receipt lives, read that whole file, and then return that file content to the user. Now, if you pass into the username something like /root password.txt, then at that point you have something called file traversal. And this pops up in a lot of things like PHP and can pop up if you don't sanitize your data. So that's clearly an issue, and that's called command injection. So in this case, it's looking at random files. But a more stupid example is if you take user data and you run os.command in your Python app. Well, that's kind of stupid. You probably should never do that. But that's an example of purely command injection. So again, always sanitize input. Watch for places where input is used to execute commands or interact with the underlying server. And again, never trust it. So cross-site scripting is similar to injection in the sense that we have to never trust data, but this is where you execute scripts on behalf of a user in their browser. So again, that's like injecting client-side scripts. So there's things like reflected XSS, which is when an attacker injects browser executable code within a single response. And that script is not stored within the application itself, and it's not persistent, but it will only impact users who open some kind of link that you craft, and then it executes on behalf of them. So maybe it steals their cookies. Stored is when you actually get it into the database and it renders for all users. So think about a tweet on Twitter. If they were vulnerable to XSS and you could put it into a tweet, then every person that loads that tweet, that script will run on their machine, and you can do it whatever you want at that point to their application. And DOM-based is the one where it's purely in the client-side code than in the server-side rendering. We're not going to talk about that much. So when this is successful, you can steal a lot of things, cookies, credentials, you can download malware in their machine, perform actions on their behalf, all kinds of scary things. So a good example is back in, 2011, 2012, somebody was able to post on anybody's wall, and this is this dude right here, and he reported it to Facebook. They didn't fix it, so what he did is he actually posted on Mark Zuckerberg's wall. Stupid idea, and you should not do that, but they did fix it. So that's an example of XSS in the real world, and it's pretty scary, and that stuff still happens. So a good example here is we have another Flask registration confirm, and then you confirm your registration with this code. You call some function that confirms the code, and then if you can't, then it renders it. Otherwise, you say, hey, you successfully registered. I wish the marquee element still existed, but it does not. So that's great. So let's actually return this string to the UI. And so what we'll do is registration confirm, and instead of putting the regular code, let's put some script in here that will actually turn to this. So back here, this will get filled with this script right here. So what we're going to do is send your cookies from your browser to my server, and then I get to log in as you. Boom. And that's a lot of fun. So you don't want to do that. So first of all, fixing that is sanitizing all inputs. This is really stupid. Do not do this. The way to get around that is just to use Flask built-in templates. There's also security headers in Django and Flask, so they do things like content security policy that will sanitize data based on, or will prevent data from executing on your, like scripts executing on your machine if it's not the right domain. Finally, this is something that neither of these will fix you against, but if you don't sanitize things like HTML attributes, so on mouse over, then what will happen is you can, when someone mouses over some element that you injected that script in, then it will still execute the XSS. So that cannot be sanitized by default by these templating systems, and that is something you have to watch out for. So again, never trust user input, always sanitize. CSRF, I won't spend too long on this, but it's essentially target state changing requests and uses, it builds off of XSS. So examples are things like making a purchase and changing an email address. And it's basically you using, let me try and explain this. So it forces an end user to execute unwanted actions on a web application where they're currently authenticated. So it does that by targeting state changing requests. And it doesn't target theft of data because you can't really see the response that you're executing on behalf of them. So the way you exploit this is you know that they have some XSS on their site, and then you use some kind of social engineering. So for example, you put up a fake login page that looks like Facebook, get the user to go there, and then they're actually not interacting with that fake site. They're interacting with the real site underneath it, and you get them to send you an email that says something like change your password, and then you get it and have their account, things like that. So the way to mitigate this is to not allow requests to have side effects. So don't allow GET requests to have side effects, but if POST requests have side effects, all you have to do is put a token into those POST requests, which Flask and Django will already do for you. And it does that by putting a random nonce into the request, and then the server will check that and confirm that it matches up. And there's no way for you to replicate that because you don't actually own their client. So the goal there is to protect state changing requests. So session management, this is a big one. This is when you want to control how your users are authenticated to your application and how they're doing things on your site. So this often will hit you if you don't store credentials securely, you have weak account management, you have a vulnerable session implementation, so things like fixation and poisoning when you leave your tokens open for too long. So this is pretty much mitigated in things like Flask Session, this other thing called Flask Session, Flask Security. There's lots of stuff for this. The goal is don't implement your own session library and use existing ones. Django's sessions library will also do this for you. Two-factor authentication helps. Using SSL helps. Anytime you can make it harder for the attacker in multiple layers to get into your application and compromise the user is always better. Because think about those attackers. If they're motivated, they might keep going. But if they're just a script kiddie or somebody that's just curious, then they're probably not going to keep going. Because personally, I can tell you I've done pen testing, and you get super frustrated and want to go home and cry. But if you are really good, or you're a nation state, you will keep trying. So put more layers in. So don't use SMS and two-factor auth. That's basically because you can compromise, or you can spoof phone numbers, and I can SMS for you for anybody's phone in here. Depends on the provider, but it's kind of unsafe now. Watch out for session limitations. So for example, subdomains can be tricky to implement, and I've linked in the end to docs and Django and Flask about their explanations on those. So again, don't store data and cookies directly. Secure your secret key. Both Flask and Django have the secret key. If you leak that, you're basically screwed. Everything uses it. And always consider session data insecure. So always treat it as if it might have been affected and deal with it properly. Keep session tokens only available for a short amount of times, and regenerate them every login. I'm going to skip through a bit of this. We got started a little late, so it'll be just a few minutes over. The proper password handling, that can lead to serious issues. Always hash your passwords with good algorithms. 2016, 412 million people's passwords were compromised because they hashed SHA-1. Why you would do that, that's awful. I know you don't have to be a security expert to Google for what is the right hashing algorithm to use. These are companies with millions of dollars in funding. Yahoo, for example. Just like last week, every single account was compromised. They just released, not only some subset, every single one. And a lot of them were with MD5, and that was published online. So that is not good, because I can crack that with my Ethereum miner rig. So here, use known hashing algorithms. The newest one is Argon 2. You might have heard of Bcrypt. You ever heard of Bcrypt? Yeah, so Bcrypt is still good. PBKDF2. Argon 2 is, as of 2015, the newest and latest and greatest, certified by NIST, people that certify all this crypto algorithms. Frameworks, both of these have them. Implement password security rules. If you're one of those people that makes you only have 6 to 8 characters with no special characters, you will burn. Do not do that. And use trusted password mechanisms. Please, do not implement your own password algorithms. Access control, I'm going to skip through this, but the general goal, the general idea is that you want to authorize only certain actions for certain people. So obviously here, this literally gives you the ticket information for some registration. Why you wouldn't require you to be logged in to get that is a terrible idea. So again, make sure the person's logged in, and only get the ticket for that specific user. People do forget this stuff, and it does pop up, so just keep it in mind. There's lots of frameworks to deal with this. Flask login, again, auth on Django. And enforce permissions and endpoints, views, and resources where it's necessary. The very last one is vulnerable libraries. So I pulled this pip list from a project I worked on 2 years ago. And you can see here, basically every single core library on it's outdated. In production, this is always hard to manage. But the goal here is just to try and update dependencies often, integrate that into CI/CD pipelines, test your dependencies as you deploy. And then you can try better development tools. So things have popped up, like pip invite, Kenneth Reads, and it makes things easier to deal with. Okay, so I'm not going to talk much about this, but the goal here is collect all your logs beyond actual web security. Knowing how things propagate through your systems is important. So there's lots of tools to do this. Threat intelligence, this one's fun. If you hear, who's heard threat intelligence? Threat hunting, any of those things? So step 1, implement your own threat intelligence. Get lots of data. Step 2, machine learning. Everybody use machine learning. Actually, threat intelligence is just gathering data, aggregating it all, adding alerts or triggers for unusual events, and not ignoring it. So we get thousands of alerts a day. Keep an eye on them and look at the ones that matter, or figure out the ones that matter. Finally, incident response is important, because if you do get breached, you have to have a process in place. Know what you're going to do if your passwords get compromised. People don't practice that enough. Finally, you can do things like have IDSs, honeypots, CDNs. Cloudflare is amazing. Other services like that, they'll give you SSL automatically. If you're building your own personal projects, that's a good way to go. So use whatever you can to throw it off attackers. So takeaways here, to wrap all of this up. This threat modeling process in general is to identify the assets you have. So again, back to the house example, protecting your keys, protecting your kids, your wife, your husband, your family, whoever it may be. Understand your application, know how you can get in, how you can get through it, how things flow around. Identify the threats and vulnerabilities, like we talked about with different security issues. Just read about it online. Just go learn about this stuff. Talk to the security person in your company. Don't let them stay in like the dark hole of a room where they are and lock them up. Prioritize and fix those issues. And takeaways from the security stuff, this will come time and time again, is never trust user input, always sanitize it. Protect secrets and credentials. Use trusted, widely used security mechanisms. If you're implementing AES yourself, that is very bad. Do not do that. Automate as much as possible. That's always helpful. And then keep as much data as you have. Keep as much data as possible in logging, because it lets you go back later and figure out how someone might have gotten in. So here's a lot of resources from this. I'll post these slides online. I'm Jared the Coder, everywhere online. Thank you so much. Glad to have you guys here.